Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to learn how to name organic compounds that have carboxylic acids as their main functional group. And so before we talk about the IUPAC nomenclature for organic compounds with carboxylic acids as their main functional group, we're going to go ahead and take a look at the structure of a carboxylic acid. And so a carboxylic acid falls under the family, the carbonyl family, such that here we have a carbonyl carbon and we have a carbonyl oxygen. And so the carbonyl group is what I'm circling in blue. And so if the carbonyl carbon is covalently bonded to this hydroxyl group, then this whole piece is known as the carboxylic acid. Now, if you have a 1 carbon carboxylic acid, then the common name of this molecule is going to be formic acid. And so if you have a carbonyl carbon that's covalently bonded to another carbon, so in other words, this is a 2 carbon carboxylic acid, then this molecule, its common name is going to be acetic acid. And acetic acid is typically what's found in vinegar. So last but not least, if the carbonyl carbon is covalently bonded directly to a benzene ring, then the name of this organic compound is going to be benzoic acid. And the carboxylic acid in benzoic acid is what I'm circling in blue. And so overall, there are 3 common carboxylic acids that you guys should just be familiar with. We have a 1 carbon carboxylic acid, a 2 carbon carboxylic acid, and in this case, it's going to be a carboxylic acid that's covalently bonded to a benzene ring. And so what we're going to learn next is the IUPAC naming of this carboxylic acid, depending on its number of carbons in the parent chain. And so the common name of formic acid, or the common name of a 1 carbon carboxylic acid, is formic acid. And it's typically found in ant and bee stings. And so formic acid is coming from the Latin name formica, meaning ant. Now its IUPAC name is going to be methanoic acid. And so acetic acid is the common name for a 2 carbon carboxylic acid. And once again, it's found in vinegar. And so acetic acid is coming from the Latin name acetum, meaning sour. The IUPAC nomenclature for acetic acid is going to be ethanoic acid. And so for a 3 carbon carboxylic acid, the common name is propionic acid, and it's coming from, it's propionic acid, this 3 carbon carboxylic acid is typically found in dairy products. So the common name for a 4 carbon carboxylic acid is called butyric acid. And that's going to be commonly found in butter, rancid butter. All right, so this is just the structure, the condensed structural formula. So here we have 1, 2, 3, 4 carbon carboxylic acid. So notice I'm including the carbon that will make up the carboxylic acid. All right. Another thing that I do want to mention for the carboxylic acid, the structure of the carboxylic acid, notice that there is 1, 2, 3 groups of electrons, or 3 bonding groups. And so this is telling us that the bond angle is going to be 120 degrees, which informs us that this is going to be trigonal planar. So the electron geometry and the molecular geometry of carboxylic acid is going to be trigonal planar. And so overall, its three-dimensional structure is going to be flat. And so the geometry really becomes relevant when we're talking about chemical reactions, but it's just good to review or to understand its three-dimensional geometry in general. All right, so how do we name these carboxylic acids using the IUPAC nomenclature system? And so very similar to what you guys have done for the past several chapters when you guys are naming organic compounds, you're going to find the longest consecutive carbon chain that contains the carboxylic acid group. And so if you recall, for aldehydes, we have an acronym for that, and that's CHO, C-H-O. So for carboxylic acid, we have C-O-O-H, or COO. And so if you guys see any variations of COOH, whether it be represented in skeletal structure, expanded structure, or condensed structure, then that functional group is representative of carboxylic acid. And so once you guys have determined the longest chain in your organic compound, you're going to change the E ending of the parent alkane or alkyne to oic acid. Now, since carboxylic acids are terminal functional groups, for example, aldehydes, right? Aldehydes occur on the ends of a carbon chain. So does a carboxylic acid. And so naming aldehydes and carboxylic acids are very similar in a sense that since they're both terminal functional groups, in other words, they're found on, they can be found on either ends and only on the ends of a long carbon chain or short carbon chain, we are going to omit one from its name. And so instead of communicating to the reader the carbon number of where carboxylic acids are found, as scientists and as organic chemists, since carboxylic acids are naturally found on the terminal ends of a long or short carbon chain, there's no reason for us to indicate the position or the carbon number of where that carboxylic acid is found, because it is always found on the ends. And this is the reason why we don't need to tell the reader that it's on carbon number 1. So from here on out, we're just going to apply all other nomenclature rules that we've discussed in prior chapters. So let's go ahead and work through a few examples just to kind of get our feet wet. And so I'm going to go ahead and find the longest carbon chain. And in this case, this is the expanded structure. Notice that I'm showing all of my carbons and my hydrogens and the double bonds and the single bonds. And so I'm just going to go through it left to right. I have 1, 2, 3, 4, 5, 6, 7. So this is a 7 carbon chain. And so if I have a 7 carbon chain, then I know that my prefix is going to be hept. And notice that along the main chain of this organic compound, I only see single bonds. And so since I only see single bonds, then I'm going to write in the suffix ane, A-N-E. And so looking at this piece right here on the right, I recognize that this is my carbonyl group, and this carbonyl carbon is covalently bonded to a hydroxyl group. And so that informs me that this whole entire structure is going to be a carboxylic acid. And so therefore, I'm going to drop the E and I'm going to add oic acid. And so there is a space that's present between the C and the A. And so overall, I would just get heptanoic acid. And if you look at all of the other attachments to each carbon, they're all hydrogens. So I really do not have any substituents. Since I do not have any substituents, no other carbon chains, halides, etc., my final name for this organic compound is heptanoic acid. All right, so let's go ahead and look at another example. So I'm going to first find my carbon chain. And by the way, the longest carbon chain should hold your carboxylic acid, right? So the carbonyl carbon on the carboxylic acid should be present in the longest carbon chain. So looking at this condensed structure, I see my COO, my COOH, so I know that this is my carboxylic acid. And so since my longest carbon chain has to contain my carboxylic acid, then that means this is going to be carbon number 1. And therefore, this is 2, 3, 4. Here's a branching point, so if I go down, this is 5. But there's all these other carbons to the left of that branching point. So I'm going to go back one step. So this is 1, 2, 3, 4, 5, 6, or 5, 6. And so it doesn't really matter because both of those CH3s are equivalent. Both of these CH3s are equivalent. And so just to make life simple, I'm just going to go from left to right, or right to left. Now, let me see here. Now that we know how many carbons we have 1, 2, 3, 4, 5, 6, we're going to go ahead and identify the prefix that we're going to use to describe 6 carbons, which in this case is going to be hex. And so in this condensed structure, since there's no double bonds found, I'm just going to go ahead and put in hexane. And so I know that I have a carboxylic acid. I'm going to drop that E, add in the OIC ending with the acid, and make sure there's a space between them. And so this is going to be hexanoic acid. And so since we have hexanoic acid, then we've described the parent chain correctly. And typically, you want to, if this was like a ketone or an alcohol, typically you would want to communicate to the reader what carbon number this carboxylic acid is found. But remember, since carboxylic acids are terminal functional groups, wherever that carbon is on that carboxylic acid, this is always carbon number 1. And so therefore, you don't need to put that 1 in front of hex to communicate that the functional group carboxylic acid is on carbon number 1, since it's always there. All right, so in terms of numbering our carbons, it looks like here we have some substituents, right? So whatever is not highlighted in pink, that's going to be our substituent. And so since we have some substituents, we need to number the carbons. Since this is always carbon number 1, then this is 2, 3, 4, 5, and 6. And so it looks like we have a methyl group on carbon 4. So I would say 4-methyl. And here I would have a 5-methyl. And so since both of these are 1 carbon substituents or methyl groups, I can combine them together and say I have 4,5-dimethyl. And then I'm going to go ahead and tack on the parent name. And so when you describe the parent name, you're going to go ahead and not add a space. So this is going to be dimethyl hexanoic acid. Now the space is going to be between the hexanoic and then the acid. But between the substituent and the name of the parent chain, there's no space. Okay, and that would be my final answer. So hopefully it's not too bad. So let's go ahead and look through some more examples just to get our feet wet, so to speak. All right, so looking at this organic compound, automatically I recognize that this is a carboxylic acid. And so that means that this carbon is always carbon number 1. Now I need to identify what my longest carbon chain is that contains my carboxylic acid. And so I have 1, 2, 3, 4. So if I go back to spaces, I have a branching point. So 1, 2, 3, 4. And so in this scenario, it doesn't really matter which path I choose or which path I take. I'll still get a 4-carbon compound. And so for a 4-carbon compound, I'm going to use bute. Now, looking at this structure, I do not see a double bond in the longest carbon chain. There is a double bond here, but that's innate for the functional group, so you don't really count that. You're looking for double bonds that's between the carbons that make up the longest carbon chain. And so since there's only single bonds, this is going to be butane. I recognize I have a carboxylic acid. And so since I have a carboxylic acid, I'm going to take this guy out and put in the OIC ending with the acid. So putting all of this together, I have butanoic acid. And so that's going to be my parent name. Now notice that I have some carbons that are not highlighted in pink. So therefore this is a substituent. It's an attachment to the parent chain. Since I have a 2-carbon substituent, then this is going to be an ethyl. And the ethyl is bonded on the second carbon with respect to the carboxylic acid. And so I'll just add on to my current name the position of this ethyl substituent. So it's going to be 2-ethyl butanoic acid. Now, typically, you would have to describe what carbon number the functional group is located in. And so typically we would say, like 1, right? Because it's on carbon number 1. But since we know that carboxylic acid is always on carbon number 1, we're going to exclude that from the name. And so therefore we are going to just move everything to the right so that we only get one word. Well, not one word. Technically there's 2 words, but this whole piece right here is just 1 word. And so our answer is going to be 2-ethyl butanoic acid. All right, so looking at our next example, here I see CO2H. So CO2H is another way to write the functional group, the carboxylic acid. And so we have COOH, we have CO2H, we have like C double bond with an O and then an OH, right? So right now there's 3 ways for us to recognize the functional group, carboxylic acid. And they're all equivalent. And so since this is carbon number 1, we're going to find the longest carbon chain that contains this carboxylic acid. So here we have 1, 2, 3, 4, 5. So if I go back 2 spaces, 1, 2, 3, 4, 5, 6. And so it looks like going straight across is going to give us the largest number of carbons in this chain. And so here we have 1, 2, 3, 4, 5, 6. So since this is a 6 carbon chain, we're going to use the prefix hex, looking at all the bonds between the carbons that's highlighted in pink. Notice that they're all single bonds. And so this is going to be hexane. Drop the E. So this is hexanoic acid. And so once we've identified that, we're going to go ahead and identify our substituent. So here we have a 2 carbon substituent. So I know that this is going to be an ethyl. And currently it's on the 3rd carbon. And so unlike the other organic compounds that we've discussed, for example, alcohols, alkenes, alkynes, etc., since the carbon on the carboxylic acid is always going to be designated as carbon number 1, there's no reason for us to go left and right or right to left when we number the carbons on the longest carbon chain or the parent chain just in general. So it just kind of makes our job very simple and streamlined and easy. And so I know that this ethyl is going to be on carbon number 3 with respect to the 1st carbon in the carboxylic acid. And this bromine group is going to be a 4-bromo. And so in total, we have two substituents, and we need to attach that to our parent chain. So we need to identify which substituent goes first. In this case, since bromine, the B in bromine, or the B in bromo, comes before the E in ethyl, the B, or just bromo in general, is going to come first. So we have 4-bromo. Since we're going from letter to another number, I need another dash. And then this is going to be ethyl. And then after that, I'm going to put in hexanoic acid. Okay. And so this is going to be my final answer for naming this specific organic compound. So in the past few examples, you've kind of just seen these carboxylic acids in either an expanded or condensed structure. So let's go ahead and look at how we would name these carboxylic acid compounds through the skeletal structure. And so when we're looking at our skeletal structure, this is pretty easy to identify. Here we have our carboxylic acid, meaning that this carbonyl carbon is always going to be carbon number 1. And so we just need to find the longest parent chain, longest consecutive carbon chain. That will constitute as our parent chain. So we have 1, 2, 3, 4, 5. Okay, so let's back up 2 steps. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5, 6. And so it looks like this path that curves down is going to give us our longest carbon chain. So that's 1, 2, 3, 4, 5, and 6. And so overall, we're going to have hexanoic acid as the name of the parent chain. So everything that's not highlighted in pink is going to represent our substituent. So here I have a 2-carbon substituent, and I already figured out my numbering system because carboxylic acids are always carbon number 1. And so since I have a 2-carbon compound, that's going to be an ethyl. And that ethyl is on carbon number 3. And so I'm going to just write 3-ethyl to represent this piece. And so looking at the next substituent, here I have a 1-carbon substituent. And therefore, it's going to be a methyl, and it's on the 4th, it's covalently bonded to the 4th carbon. So this is going to be 4-methyl. So putting both of these pieces together, the one thing that we would have to do is organize in alphabetical order. So E comes before M, and so therefore you would say 3-ethyl, and then 4-methyl. And next we're going to take our parent chain and stick it right next to the L. Okay. And so since we're going from letter to number, we need to put a dash between those 2 substituents. And this would be the name of my organic compound. 3-ethyl-4-methyl hexanoic acid. All right, so let's go ahead and take a look at the next compound here. So here we see a carboxylic acid. It's kind of upside down. And so since that's where our carboxylic acid is located, then this carbon is carbon number 1. Now this is the letter I. Okay, so that's iodine. And in this case, we only have a 3-carbon compound. And so we're going to use the prefix prop. And since we have a carboxylic acid, then that's going to be propanoic acid. And so looking at this specific carbon, carbon number 2, we have an iodine, so this is iodo. So to finish this, to finish naming this organic compound, we're going to write 2-iodo propanoic acid. And since there are no numbers between the iodine and the propanoic acid, I'm simply going to go ahead and put them together in one piece. Well, technically 2 pieces because of the space in the acid, but the main part is in one piece.